Today's objective is to be able to demonstrate your understanding of topics that we've covered so far in algebra. The first part of today's lesson is to review 4 problems from previous assignments that most people struggled with. And we're going to use these 4 problems to do a quick review before you go into your independent practice. Now for your independent practice, remember that it'll be in the form of a Google form, but you still have to show your work on a separate sheet of paper and then submit a picture of your paper at the end of the Google form. Okay, you'll do this for every question that's on your independent practice. Remember that if you submit your independent practice without proof of your work, it will be counted as missing or incomplete. So the first question that we're going to review is a question with square roots. Most of you guys know how to put these questions on the calculator already, but some of you guys are struggling with putting multiple square roots into the calculator altogether. So this is going to be a calculator review question, and we're trying to figure out what is the square root of 144 plus the square root of 49. So on your calculator, to put in that expression, first we're going to start by putting in our first square root. So I'm going to press second, and then I'm going to click x squared because the square root is right on top of it. And now I can put in 144. Now the most common mistake is that most people will continue to put in the rest of the expression under this square root, and they would put plus another square root here and go on that way. That is wrong. You do not put everything under the same square root unless it looks like that on your paper or the problem you're working on. After I put in 144, I must get out of that square root in order to put in a new one. So I'm going to use my blue right arrows to get out of that square root. And now I can put plus, add another square root, 49, to give me a value of 19. The second question that a lot of people struggle with during the task was this question over here, where we gave you different squares. We gave you the areas of the square, told you to look at the pattern of what was happening here, and then use that to figure out what the silence of a square would be if it had an area of 121. If you notice in this problem, when I had an area of 1, the silence of my square were also 1, because the way that we find the area of a square is by multiplying their sides or by taking one of the sides and squaring them, since they're the same thing. Okay, remember squares have the same, the sides of the square all have the same measurement. So in this case, I know if I have a side length of 1 and I'm going to do 1 square, it's going to give me an area of 1 unit square. Now if I have a side length of 2, then I know that the area of that square is going to be 2 square, or 2 times 2, to give me 4. Same thing with the square that has an area of 9. If I have a side length of 3, then I'm going to do 3 times 3, or 3 squared, to give me an area of 9. And if I go to the fourth example, if I have side length of 4, and I do 4 squared, okay, then I have an area of 16. Now, these questions that were asked after you looked through this pattern was asking you to figure out what the relationship between these numbers were and how now we can work backwards. So if I gave you a square and I gave you the area of the square, let's say that the area was 25, then your job was to figure out, okay, well then what do the side lengths of a square that has an area of 25 have to be? Well, then I'm looking for a number that when I multiply to itself will give me 25, because again the side lengths of a square have to be the same. So it has to be the same number that when I multiply it to itself will give me 25. Well, from the top of my head we can pretty much guess that the number that has to be would have to be 5, because 5 times 5, or 5 squared, is 25. And if we continue the pattern, then I'm asking myself, okay, well then what about if it's 36? If the area is 36, then what do the side lengths have to be? Well, again, I'm looking for 2 numbers that when I multiply them are going to give me 36. And the only number that does that is the number 6, because 6 squared, or 6 times 6, is 36. Now it's pretty easy when we know what those numbers are from the top of our head. But in a question like B, where the area now of the square is 121, now we're trying to figure out what 2 numbers, when you multiply to itself, by itself, is going to give you 121. And I can sit here and guess different numbers and try different numbers until I get 121 when I multiply it to itself. But the purpose or the relationship of this problem or the connection of this problem to our mini lesson this day is that if you once you have a number and you're trying to figure out one number when you multiply to itself gives you 121, that operation of working backwards from squaring something is called a square root, right? The opposite of me squaring something is taking the square root of it. So I know that me taking 6 and squaring it is going to give me 36. But if I want to work backwards and see what number I have squared, well, I take the square root of 36, and it's actually going to give me 6. So we're going to do the same thing here. If I take the square root of 25, it's going to give me 5 if we're working backwards. If I have the area and I'm trying to find the sides, instead of squaring it, I'm going to go backwards and square root it. So if I want to know a square that has an area of 121 and I want to know its side lengths, well, I'm going to do the opposite of squaring it. And I'm going to go ahead and square root 121 to give me sides of 11. And if I want to check my answer, okay, I'm going to take up my square. If it's 11, then that means that I have to multiply 11 by 11. And when I do that, I'll get 121. The most common mistake here is to divide by 2. To find the area of a square, you're not doing the side lengths multiplied by 2. So the opposite wouldn't be to divide by 2. Okay, to find the area, you're squaring it, you're multiplying it to itself, and so to go backwards with the area and find the side lengths, you have to square root it. So the answer here was the side lengths of a square with an area of 121 would have to be 11, because 11 squared gives me 121. A, because they put just this into their calculators and it gave them back that same exact decimal. But remember that if you see these 3 little dots, that means that that pattern is repeating itself, or that pattern is continuing. So if this essentially is 0.25, 25, 25, 25, and then a bunch of other 25s that I can continue to write there. So if I'm trying to change this into a fraction in my calculator, then all I have to do is add a lot of 25s, because that's the thing that I notice is repeating itself, and then try to convert it into a fraction. Another way that you can see a repeating decimal be written, instead of using those three little dots, you can also see 0.25 with a bar on top. That's also the same thing as 0.25, 25, 25, and a bunch of 25s going on forever. And if you're trying to put a number like that into the calculator, you can't put the 3 little dots, or you can't put the bar on top, but you can just add a bunch of the same thing that's repeating. So I can add a bunch of 25s, 25s, 25s in order to change that into a fraction. And when I do that, you'll see that this decimal is actually equivalent to 25 over 99. So that's actually a rational number. This was irrational because when I put this decimal, there's no pattern here that I can tell is repeating. And also when I put this decimal into the calculator, it's not going to give me a fraction, and it's going to give me the same thing back. Also remember, just because something doesn't have a pattern doesn't mean it's also automatically irrational. If I have something like 0.85, for example, there's no pattern here, but I can still put this into the calculator and check that it's actually going to give me a fraction. Okay, you always want to check by using your calculator whether you get a fraction or not. And then one last thing here is this last question we'll be reviewing is just making sure that you are putting the exponent where it belongs. So if I'm substituting in this 3, I'm going to rewrite it and put parentheses where it belongs. So I have -2, parentheses, and the exponent is always going to go outside. Some people are putting exponents inside of the parentheses, and it's making your expression wrong. So make sure you're putting the exponent outside of the expression. Then you have 4 parentheses 3 minus 1, and when you do that and you plug in 3, you get -43.